I offer my humble pranam at the lotus feet of Bhagavan Sri Satya Sai Baba. Welcome to video lecture on Microprocessor Laboratory. This is lecture 14, that is flag register, part 4. In part 1, part 2, part 3, I covered about status flags in detail and corresponding instructions. So in this lecture, I am going to concentrate on control flags. Now we know that I already covered about sign flag, 0, auxiliary carry flag, parity flag and carry flag and overflow flag. There are 6 flags that comes under status flags or condition flags. Explained in detail about this. If you want more information, you can watch previous videos, that is part 1, part 2, part 3, 11, 12, 13. Now in this lecture I am going to concentrate on there is a control flags, that is direction flag, interrupt flag and trap flag. You consider one by one. Now here control flags. First I am going to consider trap flag. We know that we can able to execute any program under 2 modes. One is called a run mode, another one is called a single step mode. What is the meaning of run mode? What is the meaning of run mode? Means we are going to execute complete program in a single stretch. What is the meaning of single step mode? Or it's also called trace mode. Trace mode means if you want to debug the program, we have to go for that. So if you go for 8086, there will be a function key. If you press F8, it executes only one instruction at a time. Suppose I want to check the content of register, content of memory after executing one instructions. In that case, we have to go for single step mode or trace mode, because we can able to see the output of individual instructions. If you go for a run mode, what happen? We can able to see only the final output. It is not possible to see the intermediate output. Suppose if you want to see the intermediate output, then we have to go for trace mode or single step mode. Therefore, somebody has to be there to take care of this. Suppose I want to execute instruction by instruction. We know that processor is very fast. Processor is very fast. It is not possible to do this. That's why we need somebody to control the machine. Here, control flag for controlling the processor. The status flags depends upon the final result. Okay, now control flags to control the machine, control the microprocessor. That's why here we have 3 important flags in 8086. Therefore, if trap flag is set, okay, if we set trap flag equal to 1, the microprocessor enters into single step mode, trace mode. That is, trace mode is enabled. If trap flag is 0, microprocessor enters into run mode. Okay, go. We can execute complete program. We can able to see only the final output, but here we can able to see the intermediate output. After executing one instruction, immediately we can see the output. Then we can press F8 or trace like that. Either you can go for C or C language or in assembly language. We have this facility. By the time internally, okay, if you enter into trace mode, suppose if you press F8 or if you press something like trace, immediately TF becomes 1. It enters into where? Into single step mode. If TF equal to 1, microprocessor enters into single step mode. If it is reset, microprocessor enters into run mode. So actually there is no single instruction to set trap flag. There is no single instruction. We require some push and all. Therefore in the later lecture I am going to explain how to set trap flag and how to reset trap flag. Next is interrupt enable flag. Okay, so this is another very important flag to control the interrupt operations. In 8086 we have 2 interrupts. One is called a maskable interrupt, that is INTR. Another one is NMI, non-maskable interrupt. So non-maskable means we have to serve the request. We are not supposed to ignore the request. But there will be INTR, it's a maskable interrupt. So interrupt means there will be request from outside, some other outside devices. In that case, depending upon your requirement, you can ignore the request or you can serve the request. Therefore, if you want to serve the request, this flag must be set. That is, if interrupt flag is set, that is, interrupt system is enabled. Interrupt system is enabled. If interrupt flag is reset, interrupt system is disabled. It's something like a main switch. If the main is off, what happens? The complete electrical appliances is disabled. Okay, therefore, if you want to use any electrical appliances, the main should be on. If main is on, what happens? We can able to use any electrical appliances without any problem. Here also same thing. If interrupt flag is set, means what? Interrupt system is enabled in the computer. Okay, then if interrupt flag is reset, interrupt system is disabled. It's something like it's analogous to a main switch in our electrical system. Okay, if the main is off, the complete electrical system is disabled. If main is on, enabled. In the same manner, if interrupt flag is set, interrupt system is enabled, means processor is ready to serve the request. Assume there will be request from keyboard, it's ready to serve. There will be request from mouse, request from hard disk, request from floppy disk, request from pen drive. Okay, anything, it will serve. If it is provided, interrupt flag is set. Okay, if it is reset, even there will be request, it won't serve. It won't serve. There will be request. There will be request, but it won't serve. So that's the meaning of this. Suppose I don't want to receive any call. By the time what we can do, we can put it in a silent mode, or you can switch off. But somebody keep calling, but I am not aware of it. Okay, in the same way, see, if we are not ready to serve any request, make that IF equal to 0. We have instruction for this. See here. Which instructions is used to control the interrupt flag? Your answer is this. We have two instructions. So this comes under flag control instructions. Flag control instructions. So here, clear interrupt flag and set interrupt flag. Flag is, you know what is flag? Flag is a flip flag. It is 1 bit. It is a flip flag. Okay, it's a part of flag register. Okay, here CLI. CLI is what? Clear interrupt flag. If you execute CLI, immediately it makes IF equal to 0. If you want to disable the interrupt system, execute this. If you want to enable the interrupt system, you can execute STI. What is STI? Set interrupt flag. If you execute this, interrupt flag becomes set. Means interrupt system is enabled. Clear means interrupt system is disabled. Then there will be a direction flag. The direction flag especially used in string operations. I am going to explain in later lecture. Okay, in that case, what happened? We have instruction like load string, store string, compare string, move string, all these things that comes under string manipulations. Therefore, in that case, if you want to control the direction, by the time you have to go for direction flag. So by default, direction flag is reset. Reset means auto increment. So there will be a pointer like SI, source index, and there will be DI, destination index. Therefore, if you want to increment by 1 or by 2, then this must be 0. In some cases, I want to reverse the string. Okay, I want to decrement the pointer. Okay, we want to decrement the pointer, auto decrement, like I minus minus. It is something like automatically I plus plus, like that. Okay, it's for auto increment, it's for auto decrement. Therefore, it is going to control which one, which register? SI and DI. SI and DI. Therefore, it comes under direction, it comes under string operations. Okay, now here, if direction flag is reset, by default reset only, auto increment. Then if direction flag is set, auto decrement. It decrements SI or DI by 1 or by 2. Okay. Then here also we have instructions to control this flag. Okay. What is the answer for this? That is clear direction flag and set direction flag. Therefore, if you want to go for auto increment, CLD. If you want to go for auto decrement, STD. CLD, clear direction flag is reset, and STD is set direction flag is set. Any doubts here? Therefore, this comes under flag control instructions. Still, so many instructions are there. Okay, I will cover only the important instruction required for our lab programs. Okay, any doubts here? Shall I proceed? Okay. Say I have taken some examples. I am referring this book. It's very nice book. We can refer this. That is x86 PC. It is prescribed book for our VTU. So it's very nice book. You can go through this book also. I have taken some example from this. Now here, example, show how the flag is affected by the addition of 38H and 2FH. Actually, the previous lecture, that is in lecture 11, 12, 13, and this lecture also, I am explaining flags separately, consider individually. Now actually, after performing some arithmetic operations or some logical operations, all condition flags, the status flags are affected at a time. Just I explained separately for understanding purpose. But after performing some operations, especially arithmetic logical operations, all status flags are affected. But in some cases, no flags are affected. Suppose if we go for a move instruction, no flags are affected. In general, in data transfer instruction, no flags are affected. But in arithmetic logical operations, some flags are affected or all flags are affected. That depending upon the instructions. Okay, now here show how the flags register affected by the addition of 38 and 2FH. Okay, it's very important. It's very important. So if you want to understand this, you must know the previous thing. Now move BH comma 38H. What is the meaning of this? 38H goes to BH. H for hexadecimal. Therefore, what is the value of BH? 38. Then add the content of BH, which contains 38, with 2F and place the result in BH. See here, 38 in hexadecimal. What is the binary equivalent of 38? 0 0 1 1 3. What is 8? 1 followed by 3 zeros, that is 38. 2F 2 0 0 1 0 F 4 ones. This is 15 in decimal. Therefore 38 plus 2F, just we can add. If you add these two number, that is 1 plus 0 1, here 1, 1 plus 1 0, carry 1. That will be carry from here to here. If carry from D3 to D4, actually carry flag is set. Okay, here actually carry flag is set. Then 1 plus 0, here 1 plus 1 0, there will be carry na. That carry this plus 1. 1 plus 1 0, carry 1, 3 ones. 3 ones means 3. 3 means what? What is the binary equivalent of 3? 1 1. 1 is the sum. 1 is the sum, carries 1. 1 here 0. Therefore, we have to see. What is there any carry out? No carry. Carry flag is reset. Since there is no carry behind D7. Okay, what is the status of auxiliary carry flag? The auxiliary carry flag depends on what? D3 and D4. Any carry from D3 to D4? D3 to D4? Yes. Therefore, auxiliary carry flag is set. Then, how many ones we have here? 1, 2, 3, 4, 5. 5 ones means odd parity. Parity flag is reset since there is an odd number of ones in the result. What about 0 flag? See, what is the final result? 67. Yes, 67. Is it equal to 0? No. The result is not 0. 0 flag is reset. If the result is 0, set. But result is not equal to 0 here, reset. Then sign flag entirely depending upon MSB. Entirely depending upon what? MSB. What is MSB here? 0. 0 means positive. Sign flag is reset. Okay, sign flag is reset. Here if you treat these two like an unsigned number, then carry flag. Suppose if you treat same thing as signed number. Okay, now we have to check. Here 38, 2F, 67. Okay, now here I am not considering overflow flag. If you go for overflow flag, if you want to analyze overflow flag, I already explained about this. You have to check any carry from here to here, call it as X. Any carry out, call it as Y. Then what is overflow flag? X exclusive or with Y. Set, there will be overflow. Reset, no overflow. Okay, so let's go to next example. So here one more example. Move L comma 9CH. 9C goes to L, 64 goes to DH. Add the content of L with DH and place the sum in AL. Say 9C 64. 9C 64. So we know that 12 plus 4. 12 plus 4 is how much? C is nothing but 12. 12 plus 4 16. What is the hexadecimal equivalent of 16? 10H. 0 is the sum. 0 is the sum and 1 is the carry. 9 plus 1 10. 10 plus 6 16. Once again 16 decimal. Hexadecimal equivalent of 16 is 10 and 0 is the sum and 1 is the carry. Therefore, what is the result here? 0. This is an hexadecimal addition. You can do same thing in binary also. 0 plus 0 0, 0 plus 0 0, 1 plus 1 0 carry 1, 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 1 plus 1 0 carry 1. Okay. Now see the status of all the flags. What is the status of carry flag? Set. Why? There will be carry out. D7 out. Since there is a carry behind D7. Auxiliary carry flag is set. Any carry from here to here? Yes. There will be carry from D3 to D4. Therefore, there will be carry from D3 to D4. Therefore, auxiliary carry flag is set. Then, what is the status of parity flag? Here, result is 0. How many ones we have? 0 ones. 0 means even parity. Therefore, parity flag is set. Okay. What is the final result? Result is 0. Result is 0. 0 flag is set. Since the result is 0. Okay. What about sign flag? What is MSB? 0. 0 means positive. Positive means sign flag is reset. Since D7 of the result is 0. Any doubts here? Clear? Okay. Just I explained with respect to 8-bit. Suppose if you go for 16-bit. See, it is important to note the differences between 8 and 16-bit operations in terms of impact on the flag bits. The parity bit only counts the lower 8 bits of the result and it is set accordingly. Means the parity flag depends upon 8-bit. Not for 16-bit. Suppose if you perform 16-bit manipulation, by the time it considers only lower order 8-bit, not everything, not 16-bit. Okay. Now here, move AX comma 34F5H. This is a 16-bit number. That is 34F5 goes to X. Then add the content of X, which contains 34F5 with what? 95EB. Okay, and the sum goes to where? AX. Now AX, what is the value of AX? CA is 0 after addition. Okay, so this is first number, the second number, add these two number, this is the hexadecimal result. This is binary, you can add binary 1 plus 1 0, carry 1, like this you can add binary addition. Okay, now you can see the output. Say any carry out, here any carry out, there is no carry. There is no carry behind D15. Now here if you go for a 16-bit number, the carry flag is depending upon what? Last bit, D15. Any carry from D15? No. Therefore, carry flag is reset since there is no carry behind D15. Okay. Here, auxiliary carry flag depends upon what? D3 to D4. D3 to D4. Even if it is 16-bit, it is not depending upon here, from here to here. It depends only on D3 to D4. That is low adder byte. Within low adder byte, D3 to D4. To check any carry from D3 and pass it on to D4, then only set. Here 1 plus 1 0 carry 1, 1 plus 1 0 1 carry 1, 1 plus 1 0 carry 1, 1 plus 1 0 carry 1. There will be carry from here to here. Therefore, auxiliary carry flag is set. What about parity flag? See, count total number of ones. 1, 2, 3, 4, 5, 6, 7. What is 7? It is odd number. Therefore, reset. Since there is an odd number of ones in the lower byte. See, and one more thing, sorry, here parity flag depends upon only the lower order byte, not everything. Okay, not everything. So already I mentioned the note. Therefore, the parity flag depends upon only the lower order. Say here 1, 2, 3. 3 means what? Odd number. Parity flag is reset. There is an odd number of ones in the lower byte. That's very important. Therefore, parity flag and auxiliary carry flag depends upon lower order byte. Auxiliary carry flag checks any carry from D3 to D4, accordingly it will set a reset. Parity flag check the status of lower order byte result, accordingly it will set a reset. Okay, now 0 flag depends completely on 16-bit, carry flag, all those things. Now here, what is the result? Result is not equal to 0, 0 flag is reset. What about sign flag? Set. Why? What is MSB here? Bit number 15 is 1. 1 means what? Negative. Sign flag is set. Since D15 of the result is 1. Any doubts here? Understood this? Okay, understood. This is very, very important. Very important. Therefore, the status of the flags is very important. Therefore, if you know all these 4 parts, means complete information, then definitely you can able to understand the program. Okay, this is another example. Move bx comma aah, add the content of bx with this data. Okay, now it's a hexadecimal addition. This is what? Binary addition. Okay, now here if you add these two numbers, there will be carry out. Carry flag is set. Since there is a carry behind B50, we can add these two numbers in binary addition. It's nothing but binary addition. Okay, if any carry out, then carry flag is set here. Okay, now here just 0 plus 0 0, 1 plus 1 0 carry 1, 1 plus 1 0 carry 1, 1 plus 1 0 carry 1. Means there will be carry from here to here. That's why actually carry flag is set. Now here check lower order byte. What is the status of lower order byte? Means how many ones we have here? 0 ones. 0 means what? Parity flag is set, because even number of 0 means total number of ones are 0. 0 comes under even number, therefore parity flag is set. So since there is an even number of ones in the lower byte, means actually here no ones, means 0 ones. What is 0? Even number. 0 is a even number. 1 0 is a even number, 2 is a even number, 4 is a even number. That's why parity flag is set. So what is the complete result? 16-bit result? 0. 0 flag is set since the result is 0. What about MSB, most significant bit? 0. The sign flag is reset, because if MSB 0, sign flag is reset, that is positive. If MSB equal to 1, negative, sign flag is set. Since D15 of the result is 0. Okay, any doubts? Clear? Therefore, watch all these 4 parts to understand the flags. It's very important for programming. Okay, there is another thing. Instructions such as data transfer affect no flags. Affect no flag. Instructions such as data transfer, move instruction, affect no flags. Okay, suppose here move ax comma 94c2, move bx comma 3 to 3a. Okay, then here if you assume some status, okay, no flags are affected. But after addition, there will be flags are affected. Here if you check the status after this, flag remains same. Yes, we can verify this. Understood this? That is after data transfer, even if you transfer 94c2 to ax, no flags are affected. 3 to 3eh bx, no flags are affected, means it retains the previous status as it is, no change. But after arithmetic, say addition operation, it is going to affect the flag after this. But after transferring AX to DX or DX to CX, no flags are affected. Just add these two number. Okay, now see here after add operation, the following are the flag bits. Okay, now here any carry out, no, 0. Then any carry from here to here, so definitely there will be a carry. Say 0 plus 0, 0, 1 plus 1, 0 carry 1, 1 plus 1, 0 carry 1, 1 plus 1, 0. There will be carry from D3 to D4. Therefore, auxiliary carry flag is set. What about parity? There is no ones, 0 ones, 0 is even parity, parity flag is set. What is 0 flag? If you consider complete result is not equal to 0, 0 flag is reset. What about sign flag? 1, MSP is 1, use negative number, sign flag is set. Okay, so thanks for watching. For more videos, visit my website. Thank you.